Okay, in this video, I'm going to talk about the reduction formula. The formula says a sine x plus b cosine x equals capital A sine of x plus theta, where capital A is square root of a squared plus b squared, and theta is inverse tangent of b over a. If a is positive, and we add 180 degrees or pi if a is negative. So the formula looks pretty complicated, but the idea is pretty simple. So the formula says if we add up sine and cosine functions, possibly with some coefficients, then we get something different as a single sine function with different amplitude and some phase shift. Okay, so let's take a look at the graph examples first. So I have three functions here, 2 sine x, 3 cosine x, and the sum of those two functions. 2 sine x, its graph is this. It's familiar sine graph. The amplitude is 2, so the highest point is at pi over 2, 2. The second graph is 3 cosine x. It's a little bit different graph, but it has amplitude 3. This is again a familiar cosine graph. Now let's take a look at the third graph. This is the third graph. And if you look at the green, let me hide the two functions. If you just look at the graph, it says the familiar sine wave. So we can say that this is a certain sine graph. And it's got a little bit different amplitude. It says the amplitude is 3.606. And the sine graph starts from the center at negative 0.983. This is the amount of phase shift. So by adding up two functions, sine x and cosine x, we get the third graph, but this is again a sine graph. So that's what this reduction formula is really saying. If we add up sine and cosine, we get a certain sine graph with a modified amplitude and phase shift. And the formulas down below. These formulas tell you how to figure out the values of a and theta exactly. Now in this next example, I'm going to show you how to use these formulas to convert the sum of negative 3 square root of 3 sine x and cosine x into a single sine function. Okay, so let's note here that the coefficient of sine x, the value of a, is negative square root of 3. And the coefficient of cosine x is 1. So the formula says the new amplitude, capital A, is square root of a squared plus b squared, which is negative square root of 3 squared plus 1 squared, which is square root of positive 3 plus 1, which is square root of 4, which is 2. Okay, now let's figure out the value of theta. For theta, we compute inverse tangent of b over a. So b over a is 1 over square root of negative square root of 3. So inverse tangent of negative 1 over square root of 3 is, let's bring up a calculator. So inverse tangent of negative 1 over square root of 3, and the value is negative 30 degrees. This is negative 30 degrees, but notice here that the value of a is negative, so we have to add 180 degrees to this value. Then we get 150 degrees, and if you want a radian value, you can multiply pi over 180 degrees to convert this into 5 pi over 6. So that is the value of theta. So therefore, the answer to this conversion problem is that the given function is equal to capital A, 2 times sine of x plus theta, which is 5 pi over 6. Okay, now the formula has something to do with the sum and difference identities of trigonometric functions. For this specific example, if you think about sine of x plus 5 pi over 6, and apply the sum and difference identities. This is sine x cosine 5 pi over 6 plus cosine x sine 5 pi over 6. And cosine of 5 pi over 6 and sine 5 pi over 6, if we use the unit circle, and the angle is 150 degrees. Here we have the xy coordinates of negative square root of 3 over 2, comma 1/2. So the x coordinate represents the value of cosine. So that's negative square root of 3 over 2. And the y value, 1/2, represents the value of sine function. Now if we multiply both sides of this equation by 2, you get to cancel the denominator of the coefficients. And if you move the coefficients to the front, you recover the original function of the problem. So the reduction formula is basically applying the sum and difference identities backward. As far as the problem goes, well, it's just a matter of applying these couple of formulas. Okay, so practice a few problems, you will understand that solving a problem on reduction formulas, it's just a matter of plugging in values in the correct places.